Hello, geometry students. I hope you're doing well. Today we are doing some fun work in 11.5 in geometry on the volumes of prisms and cylinders. I'm going to go ahead and start the slide presentation. You should have your student journal handy because we're going to start with the explorations 1 and 2 on pages 334 and 335 in your journal. So go ahead and get started on those while I get the slideshow going, and then we'll be ready to go through 11.5. So hopefully you remember that to find the volume of a prism, a rectangular prism like the one in the figure, that it is the area of the base times the height. In this case, it looks like the base is a square, so you would multiply length times width times height and get the volume. Part B asks, if you look at that cylinder that prism that's kind of twisted, the question is, would there be a change to the volume of that figure? It looks like it has the same base and the same height. So hopefully you said there was no change. And then you're supposed to come up with a conjecture, and I hope you came up with that. And based on your conjecture, the volume of that second prism, even though it's twisted, should also be 32 cubic inches. On the second problem, parts A and B, you're finding the volume of a cylinder. Hopefully you remember that's also the area of the base times the height. The base is a circle, so it would be pi r squared times the height. So 2A, you should have gotten 12 pi inches cubed, and 12B should have been 375 pi inches cubed. All right, we have some vocabulary today, kind of based on the warm-up that we just talked about. Volume is the number of cubic units contained in the interior of a solid, and the formula we use is capital V equals capital BH, where B represents the area of the base and H is the height of the prism. If it is a cylinder, then the V equals BH stands for V equals pi r squared H because the base is a circle. Cavalieri's principle is based on what we talked about in the warm-up, where if two solids have the same height and same cross-sectional area at every level, they have the same volume. So in other words, it doesn't matter if you twist it, if it has the same base area and the same height, it's going to have the same volume. Another thing that's going to come up in today's lesson is density. Density is the amount of matter in a given unit of volume. So to find the density of something, you take its mass and divide by its volume. We're going to also talk about similar solids. Two solids of the same type with equal ratios of corresponding linear measures, such as the height or the radius. You take the scale factor or whatever it is between those two similar figures and cube it to get the ratio of the volumes. Let's go ahead and look at some extra practice on page 337. One of the things that students get a little bit confused is when you're trying to find the volume of a figure and you're talking about the base. The base isn't necessarily the bottom part. So if I look at this figure here, this kind of looks like its base. What you have to remember when you're figuring out the bases of a prism, the bases are the two pieces that are parallel to each other. So if I look at this shape here and this shape back here, they're both triangles. Those are the pieces that are parallel to each other, and those represent the bases. These other rectangular pieces on the sides, that would be the lateral area. But if I want to find the volume, I need the area of the base multiplied times the height. That's our volume formula. I'm going to grab my pen. Let's go with blue. All right, so we have that volume equals the base area times the height. Now, over here, I'm going to write down that our base is a triangle. So if I just want the area of that triangle piece, I'm going to have 1/2, and I'm only looking at the triangle right now. I'm just looking at this part of the figure right up here, right, just this. So I have 1/2 times its base, which is 3, times its height, which is 1.5. Right, that's just for the triangle piece, This piece down here, where the 5 is, that's the height of our prism. So when we put it all together in the volume formula, we're going to have, just for our big B, we had 1/2 times 3 times 1.5. But now we take that base area and multiply it times the height, and granted the shape is kind of on its side, but our height is that 5. Now I'm going to multiply these all together to get my volume. And our volume ends up being 11.25. And then we have to be careful on our units. Anytime you're dealing with volume, it's cubic units. In this case, our units are centimeters. So we're going to write down centimeters cubed for our volume. So again, this part up here, just this piece here. This first part was our big B, and this was our H. All right, on number 4, we're jumping to number 4 on extra practice, page 337. This time we have a cylinder. So again, the volume of a cylinder is still area of the base times the height. But in this case, we know our base is a circle. So the area of a circle is pi r squared. So we're going to do pi r squared times h. All right, I'm going to fill in the numbers. We're going to have pi times, the r represents our radius. Our radius in this case is 2 squared times the height, and the height of the cylinder is 11 centimeters. So I'm going to simplify. 2 squared is 4. 4 times 11 is 44. So we end up with 44 pi. Or if you want to multiply that out, it ends up being 138.23. And again, I look at my units, it's centimeters, so it's centimeters cubed if I'm talking about volume. All right, let's look at our next slide. This time it says find the height of a cylinder with base radius 8 inches and a volume of 2010 inches cubed. So this time we know the volume, we know the base radius, but we don't know the height. So let me grab my pen again. So I'm going to write down the formula. So it's a cylinder, so volume equals, and remember for the base area we can substitute pi r squared when it's a cylinder. All right, so there's our formula for the volume. Then we're going to fill in what we know, which I know this volume is 2010. I can put down my pi and put down our base radius is 8 squared, but we don't know the height. All right, so I'm going to keep going. I'm going to simplify. We have that 2010 is equal to 64 pi times the height. All right, so I got to figure out the height. I'm going to switch my color here for a minute. Go back up. I'm going to divide both sides by 64 pi so that I can get the height all by itself. So I have 2010 divided by 64 pi. I divide this side by 64 pi. And when I do that, I'll be left with the height. Now be careful when you divide this, make sure that you, if you're entering it all at once on your calculator, that 64 pi is in a parentheses. Otherwise your calculator is going to do 2010 divided by 64, but it's going to multiply by pi, and we need it to divide by pi. So when I do that, I get that the height is equal to, let's see, number 5. Looks like the height is about 10 inches. I'm going to round there. So we get the height is 10 inches. Notice it's just a single dimension this time. It's just the height. So it's not cubed. It's just 10 inches. All right, number 6 says, find the area of the base of a pentagonal prism with a volume of 50 cubic centimeters and a height of 7.5 centimeters. All right, so I'm going to draw our prism here. It says it's pentagonal. All that means is the base is in the shape of a pentagon. I'm going to connect those sides. All right, it's a little hard to see here. So there's my prism. Okay. So we know we want the area of the base. So we want to know, I'm going to grab a different color again. We are trying to find, let's see if I can color this all in here. We're trying to find the area of this whole thing down here. All right. So we're trying to find B. So again, the volume is equal to the base area times the height. Right? In this case, we know the volume is 50 cubic centimeters. We don't know the base area. That's what we're trying to find. But we know the height is 7.5 centimeters. Right? This is multiplication here between these two. So if I want to undo it, I divide both sides by 7.5. And I get that my base is equal to, looks like it's about, when I divided, it was about 6.6 repeating. Okay. And since we're working with decimals, I'm going to go ahead and write that the base area is equal to, and that would round to about 6.7. And this time our units are in square centimeters because it's the base area, and area is square units. So the base is 6.7 square centimeters. All right, this time we have a cylinder. It's on its side, but that's not going to fool us. All right, there's our base. It says find the missing dimension. So this time we know the volume. We know the height, even though it's on its side. 6 is the height. What we don't know is this radius here. All right, so in this case, they have the radius labeled P. So again, for a cylinder, remember the volume is pi r squared times the height. So I'm going to fill in what I know. So 75.36 is equal to pi times, okay, we don't know the radius and they're calling it P, so I'm going to put a P in there in place of the R squared times, and our height, and even though the cylinder it's on its side, that's still the height, is that distance between the two bases is 6 inches. All right, so I'm going to simplify a little bit. I have 75.36 is equal to, I'm going to put the 6 in front, 6 pi times P squared. Okay, I'm trying to get the P squared all by itself. I switch pen colors here. I'm going to divide both sides by 6 pi because I'm trying to get P squared all by itself so I can figure out P. And again, when you divide this on your calculator, put parentheses around that so you make sure that it's dividing 75.36 by both the 6 and the pi. When I do that calculation, I get that P squared, notice it's on the left, but I just divided both sides. 75.36 divided by 6 pi ends up being 3.9979. I did a bunch of decimal places, right? Then to undo p squared, because we're trying to find p, take the square root of both sides. And I get that p is equal to 1.99 inches. Or if you want to call it about 2 inches, that's fine. Okay, so we found our missing dimension. If you want to, take that, plug it back into the formula and see if it works. All right, that's it for our assignment. You have an assignment on page 631, 1 to 13 odd, 17, 19, 26, 44. This assignment is also in Schoology in a multiple choice format. Remember, you have 3 tries in Schoology to try the assignment. So if you don't like your score the first time, check your work, go back and redo it. Thanks for joining and good luck. And I'll see you next time.